Okay, so what I'm gonna do now is I'm gonna say, okay, set a breakpoint, and then the next parameter is the DLL or assembly, which is mscorelib.dll. Okay, and then we're gonna pass what is the method that you wanna wait to be executed and break on it. So in our case is the system dot reflection dot assembly dot load. If you remember, guys, this assembly.load, we saw it multiple times in previous classes, right? And we know that this one, once it is hit, it will have as an argument the object or the binary, which is going to be loaded in memory. And if we reach there, we can just dump it, and that's it. However, if this instruction is not being used by the malware, it will never hit, and there is where you start playing with the different ways to load binaries in memory so that eventually you can hit the right one. Okay, so when I click enter, see this, guys, this is very important. We saw that this instruction says adding pending breakpoints, but we don't see any address where those breakpoints are being set. Every time you hit up, you do this, you need to see the address in memory where the breakpoints, where that method was found. If you don't see it like now, it's not gonna work. If I do a go here, what is gonna happen is that this binary is gonna run, it's gonna infect my system. It doesn't matter because we're in a virtual machine, but anyways, it's gonna infect the system, and we are not gonna get any stop. Okay, so the reason of this case that is not being hit is because we are not yet loaded the mscorelib DLL, as you can see here. In order to do that, and the reason I'm explaining you this, guys, is because sometimes you put this sxc command in specific assemblies that are not enough for you to start breaking into methods. Okay, so I'm gonna do sxc ld clrgit. I know that when we stop in the clrgit, then the mscorelib is gonna be already loaded. So let's do this, enter. Now we do a go, and you can see, guys, that now we have here all these assemblies loaded. And see this, here is our mscorelib. It has ni, but it's exactly the same. I mean, it has specific differences, but for the purpose of the lab and for the purpose of what we want to do, it's exactly the same. Okay, and then after that, we see that the clrgit is being loaded. Now, guys, if I run again our breakpoint command, it should show something. You see that? So right now, this is what is working. We see the method descriptions, which are basically the methods being used and being detected. And you can see that it puts breakpoints on all the different flavors or versions of load based on the arguments received. Okay, so in theory, we're good to go now. What is the next step, guys? The next step is to click go and hopefully stop whenever this assembly.load is being called, and then we will be ready to dump the malware. Let's see. We do go, it's running, and eventually, guys, we get a hit. And if you can see here, looks like it is a hit within the app domain. So this is great. Now, how we can validate where we are? So the next thing we need to do, guys, is call a pretty cool instruction from SOS, which is the call stack. Basically, the call stack, it allows us to see which were all the different methods being called before reaching here. In managed code, guys, keep in mind that this whole SOS is about managed code, right? Because, for example, in this right side, you can see that we have all these different, call stack, but there is no context here. This is native code being executed by WinDbg. This is not managed code related, and it's not understood by WinDbg. So we need to execute managed code related instructions to understand what's going on. Okay, very important for that. So for example, here, we're gonna call this instruction, which is called clr stack. Okay, -p. This instruction is gonna be the call stack that was executed before reaching here. So we execute it. You can see, guys, that difference from here. Now we have, see, namespace, obfuscated, class, and method. So you can see the context is being managed code, being understood by the debugger. If we go all the way up, we eventually will reach the guy that we just stepped into, which is the assembly.load. Okay, guys, so this is very important to understand. Now let's analyze a little bit what happened. So here, this load byte receives one parameter, which is the raw assembly, which is this object, which is basically the address of the object. If we click here, we see that WinDbg executed this command, which is another pretty cool command from SOS, which is basically dumping the object and get the details. Okay, guys, by looking at those details, you can see that there is interesting stuff there. So the first thing that we are seeing here is this value method table. Okay, this method table, guys, what it's doing is the method is gonna tell you which are all the different methods being used by this specific assembly. Okay, and here we have another pretty cool instruction that is going to tell us what is that. Okay, so that instruction is called dump md. So let's run it. Let me just grab this guy. I grab this guy, and I'm going to do a dump empty dash md, which is method description, and then we pass that value. And you can see, guys, that now we can also see all the different methods or functions being used by this object or assembly. In the left side of the column, we have the entry, which is basically the address where this specific function is loaded in memory. Then we have the method description, which is like the label of each of these methods in managed code, right? So that we can even set breakpoints on that. Here is where we can have another pretty cool instruction, which is called actually is the bpmd, but in this time we're gonna pass the md parameter, and here we can pass the method description where we're gonna break into. Let's say that we're gonna break into the get hash code. So I can just grab this guy, okay, and tell, hey, do a breakpoint on this method. And you can see that right away, set a breakpoint on get hash code. As you can see, guys, we are accessing the actual methods from managed code, so that whenever these methods are being executed by the JIT into native code, this is native code here, is going to hit the breakpoint. Okay, so I just want to show you quickly those, because I think those are very interesting. So now let's go back to where we were executing those breakpoints, right? We were dumping the object, as you remember. We were here, and I was describing this method table. Now, let's see here, guys. We have this size of the object, and let's see this beauty. We have the famous MC, which is the header of a binary. In other words, this object that we are seeing is actually a binary ready loaded in memory, which, as you can see, it was totally different approach than going step by step in dnSpy, which, if you remember, we were just going crazy. Okay, so now let's dump it. If I do R to print the register values, we can see that this object is actually being stored in ECX and in EBX. In other words, these guys, at the moment of the breakpoint, they hold the address of that object. So we can quickly do a db on that address. Sorry, well, whatever is the same on the register, and you can see, guys, that the first values is like a word, okay, and then we have another value which is the size, And if you compare this size with this size, is off by C bytes or 12 bytes. And the reason of that is because here is the size of the binary plus the object. That's the main difference. But here, this guy here is the size of the binary only. And here we have the beginning of the offset. With that information, guys, we are ready to dump the binary. So what we need to do is just put a write mem. Okay, the next argument is gonna be the path where we wanna store this dump. So let me just grab this path. Actually, not this one. Let me just go to the path where we have our lab. So it is in labs. Okay, it is in .NET. It is in 3, I guess. Yeah, it is here. Okay, so I'm gonna grab this path because I wanna save right there our dump. Okay, I grab it. So I said, let's call this guy stage2.bin. Okay, and then the next parameter, guys, that we need to pass is the offset where this binary is located. As you can see, the offset is right here, which is at offset 8. So what we can do here is we can say, hey, ECX value plus 8 is where is the offset of the binary, and finally we need to pass the size to be dumped, which in this case is the size of the binary. So we do L question mark, then we put POI. POI, what it does is it will give you the value of the address it is pointing to. In this case, we'll say, hey, ECX plus 4, wherever the value it is, which in this case, as you can see, is right here, just pass it, which is the size, okay? So we do enter, and we see that we just wrote B40 bytes here, and hopefully we got this guy decoded. So let's see. So quickly we go here. We can see that we have the dump here, which is great. So let's try to open it up now within dnSpy, assuming it is a .NET, because if it is not a .NET, if it is a traditional executable or DLL, then we need to open IDA or any other tool. But let's assume that it is a .NET. So we go here. Here's our guy. Double click and see, we right away get the proper format, because if it is not .NET, we will get not parsing here. But here in this case, sorry guys, but my whatever. Anyways, my throat is kind of bad. So we can see, guys, that here we have all the different functions. So we can see the meat, right away. We see these Chinese characters. We see this get process ID. We get a lot of meat. Which is definitely the meat, is the carnita, is what we really need, right? So that's exactly what we were looking for, guys. So as you can see, we were able to go quickly to WinDbg, find a different strategy, and dump it from there. And that's way a different approach, so that in those cases where it's totally obfuscated and we don't want to go through dnSpy, we have the second option. Now, let me show you how you can do this, but in an automated way. So normally you will do an analysis of a binary, then or assembly, and then you will see how you can load it manually, as we did. But then you need to automate it, because you need to escalate this, right? What if tomorrow you get 200 samples of the same? You don't want to be, dumping the second stage manually, right? So one of the options we can do is by using WinDbg scripts. Let me open that guy. So what I have here, guys, is a bat file, which is this guy. This bat file is basically calling the WinDbg debugger, but the command line version, the scriptable one. So you pass the C command. This from here is just syntax. you don't need to worry about that. And then here you have the script that is going to be executed, and in case you want to pass a parameter, you pass it here within the same quotes, and finally you pass the executable that you want to run through the debugger. Then that script has basically the instructions. If you have done bash scripting in Linux, it's exactly the same. Whatever you type in the bash, in the prompt in Linux, in the command line, you just paste it into a file, run it with bash, and you will execute exactly as if you were doing it manually. So for WinDbg is exactly the same. See, as you can see, we're doing the SXE as we did before. We run it, then when it hits, we load the SOS, then we put a breakpoint, run it, then once it hits, we know that the object is located at ECX, so we pass it to T0. This is also syntax important because you cannot use here A0, M0. It must be T0, which is the way WinDbg understood. Then we print the array by just doing the db on that guy. Then we get the size, as you remember, +4 with POI. Then we get the size printed, and finally we dump it, and then we kill it. Okay, so this is exactly the way it works. So the only thing that I'm missing is here. Let's put a name here. This guy is stage 2. As you remember, we have this mentioned as step2.bin, but this guy, I'm just gonna name it dump. Okay, just to make it different. Okay, we get it, and now let's run it. So what I want to do is I'm going to go to this guy. I do Control-O in far editor to expand the window. I do Control-Enter so that it can select the binary that I was been pointing to, and I'm going to execute it. I do Enter. You can see, guys, it is doing exactly the same that we were seeing in WinDbg, but in the command line. We see that it eventually hits the breakpoint. We dump the whole content, as we see the MC binary there. We get the size, and finally we dump it in this binary. Okay, and we finish. We do Q to exit, Control-O to recover the window, and you can see that now we have here this guy is exactly the same guy, but now doing automatically.